Hello, everybody, and welcome to this week's engineer interview. Especially exciting this week as we're joined by two engineers, Laura Hayton and David Blissett. Now, my name is Scott and I work for Primary Engineer. Before we start, I want to say thank you all for signing up to this year's competition. It's our 10th birthday this year, so thank you very much for celebrating it with us. Now, as part of these interviews, we're going to be speaking with engineers who work on loads of different projects, all of them showing the wonderful, interesting, and exciting things that happen when you work in engineering. Although we do host these interviews live, you can catch the recordings on our YouTube channel later in the week. Now, our special guests are going to start with a presentation all about themselves and about how electricity and engineering go together, and then we're going to open up to questions from the audience. If you would like to ask a question, simply type it in the Q&A box or the chat in Teams. We unfortunately can't get audio from the audience, so if you do have a question, simply type it in. But for now, I'm going to hand over to our wonderful special guests, Laura and Dave from ABB Motion. And Laura is going to start with our presentation.
Okay, first of all, I'd just like to say thank you so much for letting me be part of this competition. Working with children and presenting to you, it really means a lot to me, so thank you. I'm just going to go a little bit through who I am, what my role is in ABB Motion and what it is that we do. As you know, engineering is such a broad term, but we work in electrical engineering for a company called ABB and we work in their motion division. But before I tell you a little bit more about what it is that we do, I'm going to tell you a bit about me. Okay, so back in the day when I was in school, those many hundreds of years ago, what I was told through sort of careers advice is the kind of jobs that I could do was I could be a teacher or I could have maybe an office job. And those are great jobs, but it wasn't what I wanted to do. And I knew that it wasn't what I wanted to do. But engineering wasn't even a possibility for me. I didn't know anything about it at all. So I kind of left school and I was really, really lost in the world. The sort of kind of jobs that were offered to me would maybe you could be a teacher, you could do an office job, and I just knew that it wasn't what I wanted to do. So this really was my journey. I left school in 2001, and I was a little bit confused. So I went and worked in hospitality and hotels. That's kind of like working in restaurants, working in hotels. And although I really enjoyed my time in that space, I just knew that it wasn't really for me. From there, I went into what was called office supply sales. So the books that you work on or the pens that you use, that's kind of what I was selling. What is it that I do? What's my job? I'm not an engineer, but I work alongside a team of really amazing engineers. So my job's a little bit different, and I think my job's pretty cool, to be fair. I'm kind of like a detective, so I'll work out who people are in the industry, who might need a little bit of help, and to go to try to make friends with them. You're probably looking at this thinking, are you crazy? These look like big boxes. This doesn't sound like much fun. Okay, well, let me tell you a story about how this works. So power is made in power plants. You'll have heard lots about power generation, whether that's renewable energy, whether that's power station. And along with people, you'll have seen these huge pylons and massive cables, and that electricity is traveling along those cables. It comes down to a substation, and then it goes to your homes and it goes to factories as well. So that's how electricity travels. And I want you to think about the water that's coming out of the tap is like atoms, and that's the atoms of electricity. And you can have that on, say, full flow. And what the tap head does as you turn it down, it actually reduces the amount of water that comes out of the tap. And this is really similar to how a variable speed drive works. We're reducing the amount of electricity that we're using. Now, this is really cool in two different aspects because it means that the things that we're controlling with electricity, we can use much more efficiently. And by that, I mean, we can control the process more easily. Say, for example, if we were making green bottles on a conveyor line. If we didn't have a variable speed drive, that conveyor line might go really quickly and all the bottles would fall off. But by using the variable speed drive, we can slow it right down and make it a much more smoother transition. But another reason why using variable speed drives is cool is because actually we can save loads of electricity. So when we actually started to put motors in place, they weren't particularly used that well. So a lot of the network where we have industry can be using too much electricity. So this is the reason why I really fell in love with electrical engineering, because I knew that I could go to places and really help people work out how they could save energy. Okay, cool places I get to go. My job's brilliant. Like I said, I get to go find people that I can make friends with and go to the places that they work. Because I've done that, I've been to some really fun places, one of which is called the Winsford Salt Mine. And it looks so pretty and beautiful here on the picture on the left. But actually, the salt mine is 2 miles underground. Now, we've just had a snow over the past few days. When the gritters go on the road, they've been spreading salt all over the road so the cars don't slip. And this is what we're getting out of the salt mine. So you can see here me next to this huge digger. I'm a real life-size person, so actually that is huge. The picture in the middle is one of my engineers, and he's working on this product in the middle. And this is kind of like the brain of the process that we're looking at. And the picture here on the right is a digger actually extracting salt out of the walls. So that salt gets fed back through onto a conveyor belt, and then the salt goes all the way to the top of the ground, ready for the salt to be spread on the roads. And this is a great topic to consider where we've come from to where we are now. And what I mean by this is the evolution of ideas, okay? So let's think about these huge salt caves that we have underground. The salt's already gone on the roads, so we've got these empty spaces. What do we do now with these empty spaces? What could we do? Okay, the evolution of ideas, and this is how cool things start to progress. We realised we had these huge spaces, and actually nobody could get into these spaces because it's really secure. So we decided that the police could store all their top secret information in these giant rooms underground so nobody could get to them. And that to me is what I find so fascinating about engineering, because we don't stop, everything just seems to move on. And another area for evolution of ideas. The UK has got a huge amount of oil and gas wells where we've taken the oil and gas and we've used that to sort of make diesel to fill the cars up, and we've used it for all sorts of different reasons. So actually we now have these spaces underground, and I want to ask all of you guys now a question. What do you think that we could do with these empty spaces that we have underground? Okay, A, do you think that we could make a giant ball pit for all the grown-ups to play in? Do you think, B, we could relocate Santa's workshop so that he can go on holiday in the UK? C, do you think we could have the Guinness World Records for the most baked beans in one place? Or D, do you think we could capture the carbon to really help clean up the planet? Could you ask your teachers to tell me your answer, what you think? Scott, have we got any answers coming through?
We do. We've got a few people guessing D.
You guys are so clever. You're born engineers. Absolutely. We want to clean up the planet. So what the engineers have decided to do now is capture all that carbon that's coming out of the process and store it underground safely. And this is what is now being called the energy transition. Okay, we've gone through the evolution of ideas. We've gone through cool places that I've been. But I want to talk about cool places now that we can find variable speed drives. Now, I know that it looks like a big metal box and that doesn't sound very exciting, but guess what? We use them in some really amazing places, one of which is NASA's wind tunnel. We've got the biggest variable speed drive here, which is 101 megawatts. That might not mean anything to you, but believe me, that is enormous. And what NASA are using it for is to power these giant fans to test aircraft flying at transonic speeds. Another cool place, wind tunnels for indoor skydiving. You might have seen these places about, but we've got a variable speed drive on this to turn the fans up and to turn the fans down. So all these guys can have a great time playing in the wind tunnels. The real message to you guys, the world as we see it was created by engineers. And this is led from dissatisfaction, wanting to make changes, and people having big imaginations and stay curious. So my message to you, the next generation of engineers will help build a better tomorrow. Stay curious, kids. Let your imaginations run wild.
Laura, thank you for that. I would just like to give a special shout out to somebody who suggested filling it with baked beans. That was my idea as well, but I think carbon capture sounds much better. We are now going to pass over to Dave, who's also got a quick presentation, and then we will get to some questions from the audience. But Dave, please share your screen and crack on.
Hello everybody, my name is Dave Blissett. I'm an area sales manager at ABB, and one of my specialities is I get involved in the electric motors. The electric motors are what Laura's inverters speed up and slow down. But my ideas for today are really just to explain what is an engineer, what do we get involved in, and what makes an engineer tick, what's interesting. So the traditional idea of an engineer from everybody is it's somebody in a set of overalls working in a factory, doing the dirty work, getting involved in technical things. Normally got lots of like STEM subjects. That's not the full picture of engineers. Engineers cover a vast range of roles and different applications. So, for example, we have here engineers. It's a really big field. We can have them working on designing roads. We can have them working in food processing plants. They can be creating robots, making industrial chemicals, or just trying to solve manufacturing or engineering problems. By problems, it might mean something like we're trying to do something better for the environment, so we're doing something more energy efficient, or it might be we're trying to do something that's never been done before. And these are the kind of challenges that makes engineering interesting. It makes you think, and it challenges you to think, how can I do that? How has somebody else done it? And that's what makes an engineer tick. It's trying to understand how things work or how you can make things better. So, who am I? So, I'm quite old. I was born in I was started school in 1981. I left school, sorry, in 1981. I have just a general. They were called CSEs and now called GCSEs. But I'm not a highly qualified person, and yet I have an interest in how things work. As a child, I would always take things apart, which would drive my parents crazy because my toys would be in pieces, and they didn't always go back together properly. But that is an engineer. It's taking things apart. It's understanding how they work or trying to, or just having an interest in it. So after I left school, I went into engineering college. I was there for 3 years. They were teaching me the methods of how to understand engineering, or the principles are. And it was kind of what I always do and always what I wanted to do. After that, I've been in industrial gearbox repairs for many years, and that is, again, it's taking things apart that's broken and fixing them. And that is your more traditional in your overalls, and you're in a factory and you're getting dirty. That's the traditional engineer. But eventually, I decided I wanted to do more, and I got involved in gearbox repair and sales. So what that really meant was I understood how to repair the gearbox. But now I wanted to go and see customers to get them to use our company. So I ended up being a salesman, which allowed me to go to many different factories. So I got to see exactly how factories work, how different companies make things. And it just, that interest in how things work just got expanded. So that's where my interest is. And I've moved from gearboxes to now electric motors, and I've been doing that for many, many years. But it's the same thing still. It's this interest in how it works, how people make things. That's what makes most engineers tick. Okay, so I'm an area sales manager. What that means is I'm a little bit like Laura. I'm looking for customers who I can try and help. So I'm trying to find customers that are maybe have a problem. Maybe something keeps breaking, they can't work out why. So I'll be asked in to work out why something's breaking and how I can stop it happening again. Or something that's happening a lot now is we're being asked, how can I make my machine use less energy? Not just to reduce the bills, the electric bills, but also for the planet, so we're not burning as much fossil fuels. So these are two very big and very interesting areas that we're all working on as engineers at the moment, and it's helping the world to be a better place. And the way we do it is we actually go to see the customer, we sit down and work out how their machines work together with them, and then we give them suggestions on how we'd actually improve that. So what is it I actually do, and what am I involved in? I'm involved in these are called electric motors, and basically what happens is if you put electricity into the top of them, this silver thing called a shaft will spin. By spinning, they are connected to many different pieces of equipment within industry, and nearly everything that moves in a factory will have an electric motor of some size on it, making it move. It is the main mover for industrial movement. And we're also seeing that the car industry is starting to change to using electric motors as well. So although they used to use engines, they're now starting to use electric motors. And that's really what's inside an electric car. It's one or two electric motors. So around about a third of the electricity generated is used to drive motors. The rest of it would be in heating and in lighting and other minor things. But the world and the population is expanding so fast that we expect the number of electric motors to double in the next 20 years. And that has a huge demand on resources of electricity, but also all the components. So we've got a big challenge to try and reduce our energy use. As Laura said earlier, 65% of the UK electricity is used within factories. So that's where our main focus is, on trying to save the planet. It's as simple as that. We're trying to help make everything so everybody's happy and warm and get all the products they want, but with a lower energy use. And so our motors are made in such a way that they use less energy, and we're constantly looking at better designs to reduce the energy they use but still do the same amount of work. And that's what all this efficiency and all industry is working towards. So where do these things go, and what kind of work do I go on? This is Thornton's chocolate factory. Who doesn't like a chocolate factory? So on this one, they wanted to change the sizes of the chocolate, and they needed to use variable speed drives and electric motors to make the bigger chocolates, but make this conveyor belt run slower. So the combination of those two, we were able to make the bigger chocolates at a slower rate, but use less energy. So we got bigger, better chocolates and a cheaper way to make them. So that's one of the applications we use for electric motors. Next one is, this is known as a Typhoon. It's a Eurofighter. And the engineers wanted to test at the ends, these ends of the wings are not actually bombs. These are something called a DAS pod. It's full of electronics that helps the plane fly. But the engineers wanted to test, how do you test these electronics without flying the plane? Well, we developed a way of mimicking the plane flying so they could test the electronics. And so that was a lot safer and it used a lot less energy. So yes, it's still a simple electric motor, but it's used in a very cool environment. The next one, it's a hospital. You think, where on earth is an electric motor going to be used in a hospital? This hospital in Coventry was treating people. They put the people on the bed here and they're treating them for skin cancer. This device here radiates a certain amount of energy, and it's used to treat the skin cancer patient, and it's hidden behind this wall here. And what we did with the electric motors and controls, we could move this unit so we could control where the patient's skin was treated and where it wasn't. So a simple electric motor is helping save people's lives with skin cancer. So it's just another challenge that engineers have. And it's the sort of thing that's, if you're interested in engineering, this is what you'll be involved in. So as Laura said earlier, the next generation of engineers will help build a better tomorrow. It might be you're treating somebody in a hospital. It might be you're helping save the planet, reducing energy costs, or you're making something nobody has ever made before. But if you're interested in that sort of thing, you have the makings of an engineer and enjoy it. And that's me finished. If you've got any questions, guys.
What inspired you to become engineers in the first place?
David?
For me, I just wanted to know how things worked. I wanted to know what made them work, and that was the start. There was that, and I wanted to learn how to make things. So.
For me, it was completely by accident. It was someone that I made friends with when I went back to school when I was older. He invited me to the company he worked for, and then I saw all the cool things that he used as an engineer and how he helped people, and that is literally how I fell in love with it. So, bit of a different path for me.
It is very cool. That's what I've begun to learn from doing so many of these interviews, is there's so many cool things out there. Now that you both are working industry, we've got a question here that says, what's your favourite part about being an engineer? What is it that you guys love about your jobs?
David?
I did two parts. One, I love the challenge of trying to solve somebody's problems. And the other one is walking away with the feeling that you've fixed it. You've helped somebody. It's as simple as that.
I'd absolutely agree with that. And I think as well, what I really love working alongside some clever engineers is actually seeing how amazing their brains are and just the types of solutions that they come up with. And it's just so cool to see people come together and really delivering solutions, and then to see the customer happy and their site working really well. So I love that.
And there's quite a lot of cool sites that you get to go to as well, by the looks of things.
Definitely.
Yeah.
Well, I'm jealous of David's chocolate factory. I want to go.
So we've got another question. We've got two questions that are quite similar. So it's, what was the first project that you started working on when you first worked for ABB? And what was the first thing you wanted to work on?
First one that I started with, well, I've actually been with ABB for about 6 months. So for me, I haven't actually worked on any like major projects as of yet. So maybe this is a good one for David.
The first one's because you don't walk into engineering and you're the expert straight away. And that's the beauty of working in engineering. You'll always find there's other engineers with more knowledge and much more experience, and you need them when you start. So your first ones you do are very simple. But one of the ones that we did early days was we helped a customer with rock crushing machines. But what they actually wanted to do was they wanted to crush landmines for clearing the landmines in certain areas.
Wow.
And I was involved in designing the machine that crushes the landmines for something to do with it's the Halo Trust, and it was Lady Diana's charity.
Ah.
Yeah, so there's lots of things on the internet about that. So if you see something to do with landmines and crushing, it's our motors and Laura's drives.
Wow. There really is everything that you can get to do, isn't there? Working with all sorts.
Yeah.
So we've got a question in here from Miss Carruthers. Now, you've both talked about one of the things you love about the job is solving problems. And what Miss Carruthers asks is, do you always know how to fix the problem as soon as you come across it? Or does it involve a bit of thinking with the rest of your team?
Lots of thinking, lots of thinking. And also, it might be something that you've experienced before working with somebody else, so that might come quite quickly to you. But you might have to work alongside your team of engineers and say, hey, we found this problem. Has anyone got any great ideas that we can use? And that's how you collaborate as a team to bring those ideas together to give the solution to the client, basically.
I totally agree. You do not know the answer straight away. That's part of the fun. And you run away and find somebody who might be able to help you.
Find a grown-up.
Yes.
Well, we've got another question coming in here, and it's a bit to do with what you both were like when you were younger. What subjects did you study in school?
I've always been fascinated by maths. I've always really loved people, and I've always been pretty, I'd say outgoing. My mum might say crazy. But sort of bringing all that together was a great fit for me to go out and do the sales and find the solutions. But the maths part of it, physics, sciences, yeah, all subjects that I loved.
I agree again. I am happy with maths and physics. I'm not very good at spelling.
Well, we've got some other questions in here, and again, two of them are quite similar, so I'm going to roll them into one. It is, what would you do if you weren't an engineer, and is there something you wanted to be before you became an engineer?
So I definitely wanted to be a pop star. Maybe when I was about 10. Like I said, on my journey, I was pretty lost. I didn't know what I wanted to do. I know that if I wasn't doing sales in electrical engineering, I would be doing sales in some other capacity because I love people and delivering solutions. And you can have solutions in any type of sales that you do. It just so happened that I fell in love with an industry that, that I'd got to do that.
I wanted to be a professional footballer. Doesn't everyone?
So I could have been a pop star and you could have been a footballer.
What a match.
Oh, brilliant. So, well, it's good because you always have dreams, but then you fall into something that it sounds like you both really love as well.
Yeah,
I think if
definitely.
you get involved in something you love, then it doesn't become so much work. It becomes something you enjoy doing. And so
I agree with that.
Yeah.
I agree with that totally.
So we've got another question here, and it's Laura, you mentioned something about the evolution of ideas and about what comes next. And Dave, you also talked about the increased demand we're going to have on things like electrical motors. So my question is, what's the next big idea?
Well, we're actually going through something at the moment called the energy transition, which means that and this is a giant idea that we're going through at the moment, because we're trying to get rid of all the fossil fuels. So we're changing the way that actually we work as the whole world works. So do you have any bigger ideas in the energy transition at the minute, Dave?
No, it's things like carbon capture.
Yeah.
It's where we're trying to generate electricity from hydrogen rather than fossil fuel burning.
Yeah.
It's the move towards electrifying vehicles. Anywhere we're burning fuel, we're trying as engineers to try and get rid of it and generate it in a better way.
Yeah.
It's climate change. That's our big thing.
Yeah.
So the energy transition is probably one of the biggest ideas that's happened in a long, long time. And it's been an idea in the making for a long time, and we're really trying to get it put into place now.
So it sounds like engineers are going to play quite an important part about helping with climate change in the future.
Yes.
They will, and they'll be highly valued. There's a lack of engineers within industry, so very sought after.
Yeah.
There's a good long employment for engineers.
Brilliant. So we've got time for a few more questions. So if anyone out there is sitting on some questions, get them in. But this one comes from Northern Primary School, and they ask, what qualifications do you need to be an engineer?
A proper engineer or an engineer like me where I get to go make friends?
Yeah, well, just working in engineering. I mean, we've found that there's so many different ways in which you can become it. I mean, both of you had different pathways to being where you are now. So,
Yeah.
and you must work with people who've been quite similar. So, for anybody out there who's thinking of taking Dave up on his offer of going into the field, what sort of things should they be looking to study?
I'll let Dave tell you the proper pathway.
Well, I'm not fully qualified, as in, because we will have people that would be what you'd call an A grade student, which might be they've got all the grades in maths, physics, chemistry, very, very intelligent. They might go into the design and much more technical side of engineering. I'm actually not as that well qualified. I've not got a degree, so I've gone through from experience from working for many years and slowly building up. So if you're not the A grade student, don't think you can't be an engineer. That's completely wrong. You can start slow and build up with experience.
Yeah. So I left doing my GCSEs. I hadn't done a degree, so I really took the long way around to get into this. If I could go back in time, I would have known at this age what I'd have liked to have gone into and used my brains more wisely through education to transition to this point a lot more quickly. So I did my GCSEs, I did A levels, and I did a lot of studying once I left school. But that's not the traditional way of an engineer.
One thing I would say is you're fully educated as an engineer. So you'll find that we are constantly going back to factories and things for extra training. So, a couple of months ago, I was back in Finland being trained by our factory
Wow.
engineers, and it's a constant thing because you get new products or you get new materials that allows new things to be achievable that weren't achievable before. So you never stop learning.
Yeah, it sounds like, and with so many new things being created and new ideas coming to life, there must be so much new to learn.
Yeah.
Oh, it's a really fun place to be right now, actually.
Brilliant. Well, I think we've got time for one more question, and I'm going to pick one from Miss Crothers, and it's when you first started doing what you do now, did you imagine this is where you would be today?
No,
No.
absolutely not. No, because when I first started doing my job, I was quite low down. So actually, to get to where I've got to now, working as one female, well, actually second female now, in a team of 30 to 40 men, it's definitely not where I thought I was going to be, but it's a cool place to be, definitely.
Brilliant. Well, just looking at the time now, I want to say thank you very much to both of you, and thank you for everyone out there who joined us. Hopefully that you have got some inspiration today, and you're going to go out there and become engineers in the making yourselves, because now it is your turn to come up with your own engineering ideas. Now, remember and send them to us once you've finished so that we can get our certificates sent out to you and then hopefully see you in person at our public exhibitions at the end of the school year. We've already started receiving entries from across the UK, so remember and get yours sent to Primary Engineer HQ. But for now, I want to say thank you very much to everyone out there, but a special thanks to our guest speakers, Laura and Dave from ABB.
Thank you.
Thank you, everyone. Have a great
Thank you so
time.
much, everyone, now.
Good luck.